Welcome everyone to Mark Voids a Warranty. In this edition, I'm going to be taking apart this Xtronic 4000 soldering station. It's going to be all sorts of fun, and I'm glad you're here with me. But before we do, I'm going to set that aside for just a moment. Last night we did a live stream where we looked at a variety of soldering stations and the ones that users preferred. Well, one of the things we forgot to do, I ran out of time to do a thermal test on this little pin seal to see how accurate, the little OLED interface is, the temperature display versus the actual tip temperature. So one of the things that we did, just to keep everything legit and legal, was we painted the tip white. And the reason for doing that was we wanted to make sure that the reflectivity of the tip didn't negatively impact the measurements. I just dripped a little white out there. I was cleaning up before I make a mess later. So you paint the tip white, you point a thermal camera at it, and then we're going to turn it on and see what it looks like. Thermal cameras like this one, this is a FLIR CX series, provide a false color image of radiated emissions, but they can also end up doing reflected emissions as well. The pin seal is now plugged in, and I'm going to turn it on here. It would probably absolutely help if I read the interface information for it, but they didn't provide any. So we're going to set this temperature to 200 degrees Celsius and then see what happens to the tip temperature as it heats up. Or at least we're going to try to. So it's plugged in now. And I'm worried I haven't done anything or done something correctly because I'm not seeing anything on that pin seal come out. This might be a short experiment, or I might have to switch to a DC power source. Let's do that, because that was the USB power source. That could be a source of issues. So I'm going to steal 12 volts from my camera. Remind me, if we go back to use the microscope, it's not going to work. Haha. Oh, don't be that way. Oh, it doesn't want to plug in. Oh, no. This might be the world's shortest experiment. Back to USB we go. Maybe we'll get lucky. Maybe we won't. I'm not entirely sure. Okay, we're set at 200. Now we just need this thing to turn on. Oh, no. All right, so absent any comments on what I'm doing wrong, I'm not seeing anything there. That is unfortunate. That would have been fun. Well, we're out of luck. So here's the issue. Sorry I did this off camera, but I can only show one at a time with this particular setup. I've got the pin seal plugged in to a 45 watt USB-C power supply. I was hoping that would be enough to allow the temperature to start increasing. But while it operates the OLED display, man, I'm not seeing anything reflecting this thing heating up at all. So it probably needs a different power source than what I'm giving it. I don't have instructions for this thing. This could just be the programming port for all I know. But that DC, even though it looks like it's a 5.5 millimeter OD, 2.5 millimeter ID, I've got 5.5, 2.5 sitting right here. I have them all over the workbench, and it just does not plug in. Doesn't even come close. So either that pin's bent or that pin is a little bit bigger than this is designed for. So we can't test the pin seal. Sorry about that, guys. That would have been fun. Okay, well, live and learn, I guess. It's just unfortunate. Well, we'll take out our disappointment with a hammer. Start smashing things. That'll be fun. Going back to, then, our Xtronics doohickey. It's a simple case design. It's two C's that kind of fold over each other. If you can imagine a C channel and a C channel, that's what holds this thing in. Will that come up? No. What did we do here? Oh, we're faded to black. We don't want that. By the way, as we go through these, feel free to always leave a comment or question if you want. I'd be happy to answer them. We are stuck in some weird mode. This is what I get for pushing too many buttons at once. All right, so here is our soldering station. And we're just going to start opening up those seashell looking things. It's a pretty easy way to put a case together and see what there is to see inside. This soldering station stopped working at some point. It's been sitting in my garage collecting dust ever since. But it was pretty cheap, so I never spent too much time trying to figure out why it stopped working. Hello, Henry. Thank you for joining us. If you came for the Pencil, sorry I wasn't better prepared. It has been one heck of a long week. Right now I'm taking apart case screws as well as the screws that hold the hot air blower in a safe position. Getting those out of the way. In my defense, Henry, that pencil came with 0 in the way of instructions. The box it came in, the little black box, I don't even think it had a logo or a website on it. All right. Other side now. And we'll have our first peek at this. One of the issues that you have with the rheostatic controls, the potentiometers that are on the front of these things, is they're very sensitive to dust and debris. So if you get dust and dirt in between the wiper and the contacts, it can cause it to really misbehave, and you can have rapid fluctuations even with just a tiny bit of movement. Okay, there we go. So here is our first peek inside. We've got a big transformer, a really large pump. I'm quite surprised at this. So it looks like there's a unused air out or air intake, which I suppose you could also hook up to be a vacuum if you wanted to. It's on these big rubber bumpers so that it can move around without transferring all of the energy into the case and making a bunch of noise. And then it's got a, why does that look like a vacuum chamber? Or is that an air reservoir? I don't know. We'll see what that stuff is. So that is our first look at the inside. I'm going to get the FLIR camera out of the way, just so we don't accidentally hit that and damage it. Pretty common of all these stations is to have a quick connect. Either, is this a 5-pin 240 degree DIN? Or is this an aviation connector? I don't really know what kind of connector that is, but they're pretty common to these things. So let's start with the iron, and then we'll dig into the case. So these irons pretty traditionally come with a variety of exchangeable tips. We've had some discussions in some previous videos about which tips to choose. Here you've got the smallest one on, and that is generally not my favorite. Uh-oh, doesn't want to come off. There we go. Okay, so I mean, one good thing is it's a nice tight fit between the heating element and the tip. The bad news is it feels like the heating element is broken. Yeah, that's not good. Might have been why this thing stopped working. I don't know. Okay. Obviously quite a bit of debris in there. And let me bring in a close-up cam so you can see a little better of what I see, because I think right now we're zoomed out a little too far. This one. So the ceramic case that surrounded that heating element is obviously broken. It's fractured, and not in a good way. So you've got a load of wire, nichrome or whatever it is that they use. You run a current through it, and it generates heat out in this end. That should still be covered in a ceramic, and then that heats up your tip. So that is what's inside your irons. Now, as far as conducting current back the other way, so that just gets energy into the tip of the iron. It's got to flow back down the metal to get back to this spring. And we've obviously taken it apart a little bit much, but we get back to this thing, and that completes the other side of the circuit. And hiding right back here at the end, we should have a thermistor or a thermocouple or something. And it looks like it goes... I'm trying to get this apart here. So we've got 3 wires. Is our thermistor on, and is that it here at the tip? Maybe. Let's find out. This thing does not want to come apart. Hi, Mark. Hi, Anuvav, Henry. It looks like you guys have a little bit of something going on in the comment section there. I don't really know what's going on there, but I hope you're having a good time. All right, this is being a little difficult. Let me grab a pair of clippers and make some forward progress. I'm going to disconnect the wire at either end of the heating element there. And what I'm looking for is something that resembles a thermocouple. All right. Oh, but it looks like I might have sent the wrong link out. I hope not. But if you are subscribed to our YouTube channel, if you go to youtube.com/ Oh, I must be doing something wrong, guys. I am so sorry. I must have the wrong RTMP. Well, it's a little late to fix it now. Okay, so now we're inside. And we've got 3 wires. So hiding deep inside this, we had the 3 wires going into this ceramic spacer. And at the other end, and it's probably among this debris field up here, we probably had our thermocouple. Then it looks like the only thing that this board does is just give a spot to interconnect everything from the iron side back into the wire harness. And then off you go. So of the soldering irons that we've taken apart recently, that has been one of the better ones. Everything was a nice tight fit. Obviously it failed, but that could have been mechanical damage. That's not necessarily a manufacturing defect. That could have been a mark defect. It's a garage. Things happen in a garage. Bad things. Unspeakable things. Boom, boom, boom. Okay, well, we'll clean up that ceramic mess in a little bit. All right. Back to overhead view. So that was kind of interesting. Haven't gotten one of those apart before. All right. Next up, we've got a rubber tube with a few wires going through it that lead out to this guy. And this is a hot air gun that you can use for rework. Basically, it allows you to heat up large portions of the board, multiple pins at once. So if you need to take something apart, this is the go-to tool. Let's see if we have the right screwdriver tip there. So this has a hose, and inside the hose are multiple wires. And I'm just going to take a look and see what's inside. Come on. Okay. Now we just have to get that rubber piece off the end, and it should theoretically open up. It does not want to. Well, if you know me at all, there's only one thing that I can do in a situation like that, and that's play Mark Smash. Yeah. Those dirty rats glued it together. Okay, so what we've got is a stainless cylinder with something on the end of it, and a wire heating element that looks kind of like a pipe cleaner. And they made it replaceable, even though they made the case difficult, if not impossible, to get in without hot air. Let's see if we can get the rest of this harness separated. So it's the same basic design as the iron. You've got a heating element that generates a lot of heat, and then this one we can actually see the thermocouple at the end that's measuring the temperature. Get that out of the way there. Where is our... There we go. Heating element, thermocouple. Very cool, huh? All right. And then I am seeing people tell me, oh man, I don't know what I did. I do not know what I did over there. That I gave you all the wrong link. I'm pretty sure I gave you the right link and I'm connected to the wrong stream. So sorry about that. It kind of crept up on me. I was busy writing content and then all of a sudden it was time. So I bet you I gave you the right link and I'm not connected to that link. So sorry about that. So let's see what we've got going on. Hi, Henry. Thank you for making it. Hi, Moto. Yeah, it's the wrong stream. I'm sorry about that, Michael. I'm connected to the wrong thing. Say Anubhav. Sorry. Sorry, Elliot. Sorry, Jesus. Let's see, Michael Smith. How much did this station cost? Michael, I would say this one was in the $60 to $70 range, 15 years ago. I haven't used it since then because it did stop working and I never got around to looking at it at why. It turns out that it was the iron was broken. It looked like mechanical damage, so I probably dropped it at some point and didn't realize it and then went to go use it again and it stopped working. So I was like, screw it. And bought a new one. Let's see. You might find a Hall effect sensor or something similar in those hot air guns. The rest that comes with some of the stations have a magnet in them, so it will cool off and shut down automatically. That's really interesting, Elliot. I don't know that we've got enough wires here for a Hall effect. We've got 2 for heating, 2 for sensing, and then 1 ground. I don't know about a Hall effect on that, buddy. But I could completely believe it in a newer iron. Hello, Raphael. So anyhow, let's keep the teardown going. And again, my apologies for directing y'all to the wrong location, or actually right now I'm at the wrong location. Streaming's hard, okay? Stop being mean to me. No, I'm kidding. It's fine. I screwed up. Hopefully y'all are liking Teach Me PCB so far. This next week is getting interesting. We're going to start buying components. Or not buying, but selecting components to buy. So if you guys want to go off the reservation a little bit and customize your design, that'll be the first chance to. Okay, so this box here, it's just, I guess, an air reservoir. Maybe it just acts like an air capacitor for this diaphragm pump. I don't know. Maybe Elliot will tell us. Okay. I don't see how to get those out. They have these rubber bumpers that are stuck in there and I can't seem to find a way to extricate them. I'm going to take out some securing screws off the back side that should allow the transformer to fall out, and that pump the rest of the way. You guys are having a little bit of a discussion right now about leaving your irons on. That is a huge problem, especially for new people and especially for veterans. Pretty much anybody. I was going to make some jokes, but I don't want to. Everybody forgets their irons from time to time. It's best to create a process in which you can't forget to leave your iron on. If you've got a little wind-up wall timer, little type thing, you could use that. That would be good. Set up, set it up on its own little circuit where all your heating element stuff will go off after a certain period of time if you don't actively work to keep it on. Those things feel like they're spinning, so. Okay, can we please get that out? There we go. One more. All right. It's glued in. They really liked using glue here. It's taken the whole connector out with it. All right. So we've got our quiet diaphragm slash vacuum pump. It did have an extra hose on it that we might have been able to use for a vacuum. I'm not entirely sure. But we're going to crack this thing open and see what's inside. Would it be possible to monitor resistance change in heating element to figure out temp? Yes, but I don't know if it would be granular enough to give you a good temperature measurement. The heating certainly does change the resistance, the active resistance of it. But by how much? You know, when you're talking about a delta of 1 or 2 degrees, then you would need a really, really, really accurate, multi-digit meter. Like, I don't know how many decimal places, so this is a guess. But you would probably need something like 4 or 5 extra decimal places off that meter measurement, and then your price is through the roof. So the thermistor is the go-to thing. Elliot said, I made a timer power strip with a solid state relay for exactly that reason. Good call, Elliot. I have a fear of leaving it on and idle and forgetting it. Yeah, it's going to happen. If you don't set up a process that forces you to restart it every now and again, you will leave that thing on overnight at some point. Certainly not good for the tip. Certainly not good for the fire insurance policy. Okay, what do we have? I have a cheapo velamin that seems to work better if I feed it some solder and let it sit a while. Is that a velamin power strip or a velamin iron? What are we talking about there? Because if it is a velamin iron, that thing needs to go in the trash yesterday. If it's the simple pencil style ones, I used to teach introductory soldering in physics. And we would just build simple kits, and those things had easily a 50% failure rate, and the failure was usually, ah, Mr. Hughes, it's burning me, at which point I'd have to tell them to stop touching it. What else do we have here? Yep, it is a velamin iron. Yeah, you might want to invest in something a little higher class. Elliot was really singing the praises of, was it the TS100, Elliot? All right, we are getting into this pump. We are about to see everything that there is to see inside a pump. Boy, I tell you, last night's live stream, that was a fun thing to do. That was the first time we did that. I don't know if any of you guys had a chance to catch it yet. But if you did you have any comments on it? Anything we could do to make it better, or what we should do our next live stream on? Okay, we are in. Got both sides removed. So it looks like this might be an intake valve. So when air comes in, it can just suck it in, but then once it builds up pressure, it can't push it back out. And then it gets diverted into these little holes past this gasket. Over on this side, we've got another one of those valve-looking things. They do look suspiciously like valves, I tell you. So all this thing does is just move back and forth many, many, many times a second. On one side, we're sucking air in. On the other side, we're pushing air out. And that sucking and pushing go through these two ports here. So that's how they're able to provide both suction and air. It just depends on which side of that thing you're at. If you pull it one way, it's going to be creating a vacuum effect, low pressure, that you can use to suck things up. And then if you valve it the other way, you can, when it's pressured, you can push it out the other way too. And then you just use valves to ignore the other side of the process. So increase pressure, decrease pressure. Reset. Increase pressure, decrease pressure. Reset. Increase pressure, decrease pressure. Reset. And that's all there is to a good old pump there. Interesting. Not much to those at all. All right. Now we're getting there. Like an aquarium pump, yep, or check valves. Absolutely. Are these screwed in or are these just press fit? These look like press fit. Sometimes knobs there's a little set screw that you have to get underneath to get them out. Oh. Get off there. We'll leave them. We'll let them live. So now we've got, before we can remove that thing, we've got to remove these screws there. And I've got a cool pair of pliers. I believe they're called Van pliers. And the cool thing is they've got serrations inside these tips that make them great for grabbing this stuff. So oftentimes you don't have to go get a nut driver to remove them, which is handy. Okay, so those are loose. One more over here. And then I see two tiny Phillips screws that I need to get to. While we're waiting, if you ever do want to get notified of my live streams, and maybe for some reason you don't trust me to provide you the right link, you can like and subscribe and hit that little bell, and you'll be notified whenever I go live. And then you can just click on it. Because I got to tell you, if I made the mistake once, I am going to make the mistake again. Okay, let's see if that comes loose. So I will say, up until the point that I broke that soldering iron, it looks like it was reasonably well designed. I mean, they're not putting a lot of money into these things. You can't and sell them cheap. But it looked fine. So right now I'm just removing the quick connects from the switches. Switches are somewhat expensive when you look at them. So whenever I get a chance, I make a box of them. And just leave them there for if I ever have something to repair. Then I don't have to go out and buy a new switch for it. All these quick connects have a retaining pin that interfaces with that little hole on the contact. And sometimes getting those things loose is a pain. Hi from Belgium. We're international, guys. In a recent video, you mentioned a book. Do you know where it can be ordered in Europe or get the ebook version? Live streams are great. Yeah, so it's Artech House Publishing, ARTECHHOUSE, and you can order it online and get an instant PDF download if you are so inclined. And I know my friend Eric would appreciate it. He's a good guy, and it is a good book. I was actually reading a little more of it this morning. He's got a lot of great advice, and if there's ever a discrepancy between what I tell you and what he tells you, do what he tells you. He's been doing this a lot longer. Eric is a genius as far as I'm concerned. Okay, so on the other side of this pass-through connector, they've got just globs of super glue, giving them an airtight seal. So the air that comes out of the pump goes down into this. It goes through the wires, which I'm sure would keep them cool too. And the air and the wires go up into the thing. We had ground, 2 for power, and 2 for sensor. All right. That problem solved. Does anybody happen to know the connector, if that is a 240-degree 5-pin DIN or something else? I would love to know, because those things show up all over the place. All right, we're making progress here. Looks like we're making such good progress, I might be able to take apart some other stuff too. All right, you know something? Let's not waste time. This thing's not going back together. And I kind of like these flush cutters too. I can't see who makes them. I'm too blind for that, and the contrast is too low. But they're real thick. They're heavy. I like them. All right. Get that out of the way. GX16 connector, maybe at least that's what they labeled them on eBay. Oh, okay. Well, there we go. All right. So what we're looking at is some old school, inexpensive technology. It's great. One-sided only. That saves on production costs. Let's see if we can zoom in, if I can find the right button here, and we can take a look at some things. Here you're going to see that they used a variety of copper widths to connect things. There's some reasons behind that. We'll talk about those in just a second. But we have our first look. Some LED displays that are probably driven by these ICs just on the other side of them. And you'll notice each one of these 7-segment displays, so that's 7, 14, 21, 28, 29, 30, 31, 32, 33, if they're using all of them. Each one of those things doesn't need its own pin. They use scanning matrix to make this work, and something called persistence of vision. So these columns and, well, what would be a good way to do it? These segments can be divided into an array of columns and rows, just kind of like the switch matrix that I talked about in our class. And if you pull a column at the same time that you do a row, it'll light up one LED. So these things are connected in such a way that it'll light up one column and, you know, use that as an anode and use the other column as a cathode. And that'll light up one pin. If it activates another column or another row, well, then it can activate another. So it'll go through, and it'll go through every iteration that there is to go through, and individually light up each one of those things, or all of them. Now, the human eye can only see so many things per second. And if you get a bright flash of light, and it happens fast enough, and then it happens again, and it happens again, it looks continuous to us. That's the persistence of vision type thing. Now, if you view it with a high-speed camera, you can actually see which ones are lit at what time. But not all of these things are lit at the same time, which is pretty fascinating stuff. All right, so here we've got some potentiometers. There are linear and logarithmic pots. These are linear, I believe. And they're probably 5 or 10 Ks. The linears have a resistive element. You know something? Let's just pop it open. Why talk when you can demonstrate, right? There's that. There's There's that. As soon as I get these loose, I'm going to cut it out of its frame. There's that. There's that. Okay. Let's see to what level I can disconnect it. Not much more than that, I don't think. I want more. Will that pry off? I don't think so. Okay. Well, anyhow, you've got a tiny little PCB here. And on that PCB, you've got a resistive surface element. And that goes in kind of a horseshoe shape from this outside pin to this outside pin. So it goes pin, resistive stuff, pin. And on the inside, you've got a wiper that moves around and contacts in different spots. So there you can see it near my thumb. It's moving up to the center and then back down. So that wiper rubs over that resistive stuff. And depending on how much resistive stuff there is between a given leg and the wiper, that tells you how much resistance there is. The further you go, the more resistance there is. On a linear wiper, a linear potentiometer like this, it really is a one-to-one conversion. The further you go, the more resistance you have. But you can modify these with logarithmic wipers they use for audio devices by not laying down a consistent base of material. So anyways, I always thought those were interesting, but they are quite susceptible to dirt and dust. If you get some schmutz in there, you know, by leaving this thing out in a garage, for example, it can really do a number on things. So let's take a look, if we can, at some solder. I guess we'll do this side. We are bringing up a new camera view today, never before seen on Mark Voids a Warranty. And we're going to hope it works today. We tried to be seen before and it didn't. Okay. Are we focused? I don't know. Let's try this. I feel like we could do a little bit of a better job focusing. So what you're looking for in a soldered joint is that let me get a reference here. Where is it? Oh, it's over here. What you're looking for in a soldered joint is that there's a little bit of a fillet that it starts to climb up the side of the joint. You want it to cover the pad completely, if possible, and you want it to be shiny and clean looking. You don't want any pivots or anything around, you know, like on this through hole. See how there's a little bit of a shadow back there? You have to worry about there being this thing called a cold solder joint, or the flux attaching itself and creating a hole around the pin. Let's keep looking. See if we can see any. You don't need so much solder that it starts to blob, though. Like here, there's a little bit much. And you don't want to leave the flux on the board. See this schmutz here? Because flux is an acid, and over time it will sit there and destroy the connection. There's our other potentiometer. Here's our LEDs. This is kind of fun, huh? I need to find a way to improve the focus ability. So I think I'm going to abandon this view for now until I get a little bit of a better way to control it. right now I'm holding everything by hand and it's messy and I'm hitting things. So anyways, that's a new view on Mark voids a warranty. How fun is that? All right. Any questions on this board before I move on to another iron? I'd be happy to entertain them. There are a lot of components. These are all through hole. That's just when this board was built, probably or designed, surface mount stuff didn't exist. And that's okay. I mean, that's the way stuff used to work. But if we don't have any, I'm going to move on to one of my disposable solder irons. Is there a flux cleaner or something flux will dissolve it? Yes, there is. There is a can. I don't have it within microphone reach. No, I can't get to it. If you look on Amazon for flux remover, you can get some in a propellant can, either by CRC or Kim something or other. But yeah, you can buy it and it just destroys the stuff. It's great. So if you Google it, I'm sure you're going to find it. And if I think of it when I update this stream, I will add to it. All right. For our next sacrifice of the day, boom, boom, boom. You should see this workbench right now. This is bad. I'm making a mess. That should have been the title of this series, Mark Makes a Mess. But anyways, so now we've got our El Cheapo $10 iron from Amazon. And all this thing has is a potentiometer with a sticker on it for temperature calibration. And we found out when we used the thermal camera with it that at the lowest temperature setting, it's already at 280, 290 degrees Celsius. And that's when it says, sticker-wise that it's going to be, like 180. So it ventures like 100 degrees C out. So we're just going to pop this thing apart. One of the complaints with these guys, and it's a valid complaint, and Elliot pointed it out, there's a loose connection between the heating element and the tip. Well, that's horrible. Because air is an excellent insulator, so you're not going to be transferring that thermal energy very efficiently. Okay, tell you what we're going to do here. We're just going to delete that wire and pop that and see if we can't pull it right out. There we go. All right, so on this board, we've got our reasons why. There is but a heating element. If you look, there's just two wires, here and here, right? There is nothing in the way of a sensing element that goes in here. If we broke it, actually it's kind of hard to do and I don't want to get cut, so I'm not going to do it right now. But if we broke it, we would still see that wound wire, but there's nothing in here to record temperature. We've got a transistor of some sort, so it takes AC power in. Man, there's a resistor to step down for the LED, a potentiometer that may or may not do something. I don't know. Wow. A diode for rectification and heating element. Yeah, about the only thing this thing can do is have a sticker to verify it. That's pretty crazy. Huh. Okay, so Henry says, if we have time for it, I'd like to see what the camera says about Pencil's thermals. I would too. I actually tried it at the beginning of this stream. And I have two issues, but maybe since now that I have people here, you guys can help me solve them. So one issue was that when I had it plugged in through the USB-C, it didn't heat up at all. And then the second issue was I tried plugging in a 5.5 millimeter connector. Which camera am I on? And it just didn't fit. It didn't go. And this thing came with nothing in the way of instructions. So if you guys can offer some advice, I would be happy to hear it. Open loop. Yes, Elliot, it is. It's an open loop system, and that's one of the reasons that it's so bad at setting temperature. It's also the reason I was more than happy to sacrifice this one. It's a piece of crap. Perhaps it could be sensing change in current. It's not. There's nothing here that senses anything. These are all active components. There's no sensor at all. Diode is doing rectification. It's not doing anything. Diodes can sometimes do some stuff with current. You've got resistors that are just dropping voltage. They're just heating up. No, there's nothing here that could possibly sensing anything. It's just an open loop. It's a sticker. It's sticker verification. But back to the pencil for a moment. If y'all have an idea of what connector I need here, I can order one, and then I can do the thermal measurements on the pencil. But if not, that's cool too. I'll give you a minute because it takes a minute to catch up. All right, and just to verify, so here when I have it plugged in, I can get the menu and whatnot to run. It says for the USB, do you have a USB PD charger? I'll show you what I'm using. Oh. This is a 65 watt USB-C fast charger. I don't know if that is the right one or not. Like I said, this thing didn't really come with any instructions, so I just figured that was the best power block that I've got, but I don't know. Is the pine tip all the way in? I thought I said tip not connected thing on the idle screen in the previous vid, but I'm not sure. Not isolated, so 50-50 chance of applying mains voltage to your board when soldering, depending on which way you plug it in. Parallel logic, yes and no. For single phase power, there's it's called hot and common. I'm sorry, it took me a second there to think of it. But it's alternating back and forth the whole time. So if you do plug it in backwards, you're just going to be catching the negative phase and rectifying that versus the positive phase and rectifying that. Is the pines tip all the way in? I think it's all the way in. Let me plug this back in and I'll double check. And if not, we're going to end a couple minutes early, something that never happens on Mark Voids of Warranty. Does that look okay? We've got a triple X, and I'm thinking the exclamation points and the X means I don't have sufficient power. So I think that's going to end this experiment until I go out and figure out. I thought that was a 5.5, 2.5 millimeter tip. I don't think it is anymore because my 5.5, 2.5 doesn't fit. So I will have to figure that out and do the experiment and come back to you. All right. With that, you again have my apologies for giving you the wrong link. It was actually the right link, and I'm connected to the wrong stream. It says, yo, it has some error. If the power is insufficient, mine says DC low. Okay. I will have to read. You're seeing the tip error. Oh, let's try that. It wasn't in far enough. We're not done. Now, oh, the error's gone. Oh, you guys are good. You're good. Let's see. Is it going to heat up? It's heating up. Thermal camera time. You know something? If y'all hadn't been here with me right now, I have to say, I probably wouldn't. Well, first of all, I'm pretty dang busy right now with everything going on, so I wouldn't have gotten back to that anytime soon. But if I did, who knows how long I would have spent messing around trying to figure that out, you know? Oh, look at that. Sexy thing right there. Nice hot iron. Okay. So, the pencil is fluctuating around 205, 206 degrees Celsius. Come here, buddy. Oh, I got an angry cat. So our display is at about, well, it's fluctuating a little. Let me see if I can bring them both. But it looks like our temperature is at a pretty consistent 224. Let's do a overhead wide view. So it fluctuates between about 205, 210. I don't know if that's normal or not. And the pencil tip on the thermal cam is showing at about 225. So this is about 20 degrees Celsius over what we would expect. No, actually not even 20. I mean, since that's fluctuating so much, it fluctuates between 10 and 15 from the display. That's not too bad. 15 and 20. That is the best of all of the ones that we've seen so far. Most of them were 20 or 30 degrees over. We had the cheapo that was, 80 degrees over. So that's not bad at all. So the pencil works. Nice job, everyone. Teamwork makes the dream work. All right, do you have any other questions on the pencil while I have it out? You want me to, let's do a temperature increase here. And so even though the set point was at 200, it was measuring 205 to whatever. I just bumped the set point up to 230. We're going to see what it says. Whoops. Making you guys motion sick out there. Okay, so I set the set point to 230. It's reading 230 to 240. It fluctuates quite a bit. And on our FLIR, we're reading 260. So if everything is accurate, it's about 20 degrees over set point on this. Yeah, that is very good compared to the previous items. Very much so. I think it's possible to calibrate it too. I'm not sure how though. Neither am I. I haven't. You guys are watching me play with this pretty much for the first time today. What's the heat capacity like on the pencil? Does it choke on ground planes? That is a really good question, Michael. You need a device that can dump enough energy in to heat up the copper quickly in the area that you're working. I have no idea on this guy. Never ever used it. Oh, and it's going to sleep. Haha, it noticed I wasn't moving. That's great. Elliot says, I would argue that the consistency is more important than the number it says, and yeah, you can calibrate it. Abso-freaking-lutely. If it's consistently over by a certain degree, you could make that adjustment. Now, the other thing too, we're assuming that I have my FLIR calibration. I mean, it was calibrated in July, but we're assuming that it's the thing to be believed. Really, what we would do if it was me and I wanted to figure it out, I would use some solders that have different set point or different transition temperatures and see at what temperature those things transition, because the phase transition is going to happen at a very particular temperature. So that would be one way to do it. Any other questions? Desolder something on the board you just took apart. Okay. We've got a slight issue, though, that we have to take care of. Do I have... All right, so that is clean-ish. I'm going to, let's go back to overhead view with messy overhead view. So I've got some solder paste that I need to recycle. So I'm going to use that to tin the tip. You want your tip to be shiny and clean. What do we have here that would be easy to desolder? LED maybe? Let's see. There's one leg. There's two. Worked great. So let's find a big copper plane and dump some heat into it, like that copper pour. Do we have a connection to it somewhere? I guess right there. So let's see what happens to the temperature as I just start heating up this location. So I'm going to do the location off screen so we can see what happens to the pin seal on. So that spot is hot and it seems to be maintaining temp. Huh. Okay, and I'm still dumping heat into the board. That thing would have come out long ago. So that's pretty good. I see why you guys like these. Is there a big difference between the was it the T100 and the pencil? I don't know, but I'm reasonably impressed by this. I'd be even more impressed if I can get different tips. I'm not a big fan of that tip. So, okay. Well, that really changed my afternoon. Thank you for that. I appreciate you guys helping. It says, Michael, a friend told me it can have issues if you're heat conducting straight into a big ground plane, but you can also easily boost the temperature by holding the plus button for a while. Boost mode! Bum, bum, bum. They should call it beast mode, I think. All right, guys, that is it. We are over an hour. Thank you all for joining me today. Again, my apologies on the stream. I promise not to let that happen again today. I promise today. No, I don't. I screw things up all the time. I'm not going to lie to you. It could happen again today if I go live again. But I really do appreciate you spending your afternoons with me, your lunch breaks. And I'm going to get back to writing content for our course. And I'll see you guys in there. It's been great. Thank you so much and have a great rest of the day. We'll see you on the next stream. Bye.